Good morning, everybody. Let's start today's lecture. Can we do this? Thank you. Just start from here. Doesn't matter. Doesn't matter. You just sign it. You don't have a pen. You have a hat, but you don't have a pen. Okay. We started talking about templates. We gave a number of examples for the templated functions, and then we said that we are going to apply the same idea to the classes, templated classes, and I think I gave you this. Yeah, this example. A class template definition. All you say is that, okay, I have a class pair, okay, and I think we did this before. I think it was a character pair or something like that, okay. Now I have this, and I am going to make it templated by putting this template specification at the top of the class, and I say that I am going to use this generic type name T inside my class definition. And I say that I have two private data members, their types are T. Okay, I don't know the types yet, so during the compile time, whoever uses this class will specify the types, and I will get the T type from the specification. Okay, so this is the class declaration. How about the implementation of those functions? Well, each function is like a templated function, right? So when I write this set first function, it's a templated function that depends on T. That's how I am going to write it. For example, the set first is written this way. You say that I am writing a templated function. It is based on this class T, but this function is part of this class pair T. Okay? It's not part of a class named pair. It is pair T because it's a templated class, okay? Inside the templated class, I have this function set first, and it takes an argument of type T, and it sets the values like that, okay? So this is how you write it, and of course your construct is like that. So names of the functions did not change inside the class. Yeah, they are the same, but name of the class is special. It is pair T class. It's not the pair class. It is pair T class. Okay, so that's an example for a templated class. And once I do that, I can define these kind of objects like I did with the vectors, right? Remember the vectors? I can do the vector of integers, vector of characters, vector of vectors, right? For two-dimensional vectors, I can do the same thing with this now, okay? And the way you use it, you just simply use the member functions of the pair class. Set first. Is that flickering? Oh, yeah, that's flickering. Okay. I am seeing something flicker from that side. That's like that one. So it is only bothering me. It is not bothering you, right? And I am okay. The rest is the same. So you know the slide, okay? We have been using this all along this semester with the vector class, okay? And I've shown you some example of other STL classes, templated classes, like the list or set or queue, etc. Okay, and this is how you write it. And just pay attention to this notation here when you are writing the function pair T. You always keep it in here, and all the functions that you are writing for a templated class is templated functions, okay? They are all templated functions. This is a templated function and this is a templated function. Okay, let's see this one in the editor actually. What is this? I don't know what they are. Let me close them. Oh, I was checking the close all, and let me open this. Chapter number 16, and I think it is this one. No, not that one. Not that one either. Yeah. This is our pair. And class definition here templated. I will define 1, 2, 3, 4, 5, 6 templated functions. So template keyword, constructor, template keyword, template keyword. Where is the definition for the first constructor? I don't have it. Okay, template keyword here, template keyword, and that's it. Where is my no parameter constructor? Did you say it? 1, 2, 3. Some of them are missing. Set first, get first. Where is the rest? This class is incomplete. Yeah, well, it is. Okay, let's try to do this. What are we gonna do? Let's say, remember we used to say, okay, don't do that, but make it a, let's do this default argument mechanism thing, default argument options. So with the integers, I used to say 1 and 1, so that if I am overloading this pair constructor 3 times, one with 0 parameters, one with 1 parameter, one with 2 parameters. So what am I going to write here? Should I write 0 and 0? Why not? What would happen if I write this? Can I instantiate this templated class pair with day of year objects? Pair day of year in that case? Right? So 0 is not a good idea. 0 is for integers, maybe characters, maybe some doubles, I don't know. I mean, it is something for integers, okay? Some numerals. How about the day of year objects? How about the vector objects? How about any kind of object? How am I going to initialize them with this? What would you do? Who's talking? Yeah.
Null.
What?
Null.
Null pointer?
Yes, null.
Well, I mean, how can you assign a null to an integer if I am doing the pair of integers?
Maybe I will send the address of the integer.
I am not hearing what you are saying. Just say it louder.
We will send the address of the integer and it will assign this to null.
What do you mean by assigning a null to an integer or a character or a day of year? Well, I mean, you are trying to make it compile. Yes, it might compile, but it doesn't make any sense and it will crash as soon as you start using them. One thing is I can't do anything. Well, in C, C++, there is no such thing as can't. You can do everything you want. Yes?
-1?
-1?
Yeah.
How can you assign a -1 to a day of year object?
You can't. You can't because of there is a problem and maybe
You are saying that I won't be able to do pairs of day of year objects. Is that what you are saying if I do that?
could you repeat it?
If I do 0 or -1, I can't do pairs of day of year objects.
No, you can. But when you assign this, the user see the -1 and he think
How do you assign a -1 to a day of year object? It doesn't work. It will not compile. That's what I'm saying. Okay. How do you assign a -1 to a vector or a class pair, for example? So what did you do? Yeah.
Define the default constructor.
Yeah. So what would I write here? I would say maybe T, like that. So you are saying that whatever the default value of that type is, default constructor returns, I am going to do that. Okay? So this is something commonly used. So what is the, if that class doesn't have a default constructor, then this code will not compile for that class only, but you are supposed to write a no parameter constructor anyway. If you don't write it, there is a default one. If you hide it, then it's your problem with that class. Okay. Usually we do this kind of stuff. Okay. So writing generic code most of the time is easy, but sometimes you need to do this kind of. You need to make these kind of tricks. You need to find these kind of tricks, and the number of such tricks is not that high. You just look at the sample code. Look at the code of the, for example, the. Do you remember the sample code for the vector? And we said that there is actually. Well, you know what? I can even do this. I can even do this. What does that mean? If you say something like this, it means that it's a pair of integers because I did not specify the type. Okay? So these kind of tricks are available, and if you like to see what kind of tricks are available, and I mean, if you think you can figure them out, but if you like to see, just go to the definition of vector, source code of the vector in C++, source code of vector H, and in C++ you do that, and you are going to see that they use those kind of notations, and try to understand what they are doing actually, and you will realize that, oh, that's a good idea, maybe I can do that too. So it definitely makes lots of, as you see. So this template for the vector, it will take two parameters actually. One is the type name, the other one is a TP, the other one is allocator. Allocator is for how are you going to allocate your new objects? Is it going to be malloc and that kind of stuff? So there is a default one here. And for the vector, there is no default one. And again, you can just try to read this code, and you will understand. How many lines I have there? See, this is the code for the whole vector class. Of course, it comes from some other base classes, like the one that is, yeah, public. This one. How about this? Vector is a templated class, and it derives from two other templated classes. There is another vector here, and there is a safe sequence. There is a safe sequence class which is templated over a vector of TP allocator, like this one. Okay, so you get these kind of ideas by looking at the sample code like that, nicely written code. It might look a little bit complicated, but they are not actually. If you just read them carefully, it will be very, very helpful. Okay, good. So this is my class definition, and that's it. I can use it any way I like a vector object, and keep these kind of tricks in mind, because as I said before, We are writing more abstract code now, and you have to be very careful. Good. Any questions? So let's look at the other code from our book. Remember our PF array? And let's open the PF array template version of the PF array D backup. Or it is not PF array D anymore, it is just PF array. And this one, these four, open it. And I think this one is, yeah, this one is including everything. So it says, I am going to include all these CPPs along with their header files and everything. So well, I mean, that doesn't look good, but that's what we are doing actually. And in practice, they put everything inside the header files, like the vector class that I showed you a few minutes ago. So I am just saying that I have a PF array backup object of string, okay? So I can keep strings inside this PF array class. Capacity is just from the user, and I keep adding those strings to this object, and I print them out. Then I take the backup, then I empty my array, and I try to print everything, but there is nothing in it because my array is empty, and I restore it, and I print them out, and I see that it works. Okay. So let's go to pfarray.h. Obviously, it is in a namespace of its own, which is nice. And pfarray is a class. Okay, pfarray is a. Let's make this double. So by default, it is now a double pfarray, like it used to be. Okay. If you don't specify any size, it becomes a double. Okay, so that's the pref array, and I have 1, 2, 3 constructors. It is better to make this explicit again. My copy constructor, it takes an PF array again. Add element, it takes a T. Rest of them is like that. Okay, and remember the destructors? I have the virtual destructor here, and we always wrote this with another version with the const, right? Don't forget about that. Otherwise, you know what happens. So basically, I mean, I repeated everything in my pfarray class, and I replaced all the doubles with t's, and integers are there. Okay, these are not templated. Okay, so this is pfarray .h, and this is pfarray code. And I am going to implement each of those templated functions one by one. Okay, this is no parameter function. It just makes a new capacity one. And this is the one that takes the size. This is the copy constructor, and this is the add element stuff. Okay. See, this one is interesting. Even though I don't use this type T anywhere in the function implementation, I say that this is a templated class. Why? Because this is a templated function. Why? Because the function itself is part of a templated class, and I have to repeat this because the name of the class includes the template name. Okay, it is T, template type. Okay, so don't get the impression of if I don't use this T at all in the function implementation, I don't use the template header. No, you will have to use the template header all the time. If it's a part of the class, then you will have to use it. Okay, the same with the capacity, same with the get number used, etc. Okay. So assignment operators, we wrote the big tree, and so we are done. Okay, so this is our base class. Let's look at the more interesting part of derived class. Derived class says that, okay, I'm going to use this PF array. Okay. I am a templated class. I am a templated class, but I derive from another templated class. Okay. So this is our hierarchy. This is our hierarchy. I am a templated class, but I derive from another templated class. The book talks about this a little bit. Let me show you the general. Yeah, okay. This is what could happen. You have a concrete class, okay, no template class, and somebody derives from you, B. And this is what we have been doing in the inheritance chapter and the polymorphism chapter. And now I am doing this. My base class is a templated class. I am a templated class too, of the same type. Sometimes I like to do this, okay? My class is a templated class, but I am not a templated class, okay? Or my base class is a non-templated class. I am a templated class. Okay, these are all possible, and they are all commonly used. For example, let's give an example for this one. For example, I like to do this. Class PF array D. Okay, I am going to make a PF array D backup. It is double backup. Okay, I am going to make a double array backup, but I am going to base myself to public PF array double, okay, and do my class definition here. Am I a templated class? Is this PF array D backup a templated class? No, it is not. I don't need a template type for this one because I am going to use doubles in my class all the time. And since my base class is a templated class, I have to instantiate it with a double. So my picture is like this now. Okay. My base class is a templated class. I instantiated it and I did this. Okay. If I put instead of double, if I put T here, then I become a templated class. I have to include template type name T here. I become a templated class. Okay? But I don't. Now I am like this now. Okay, and the opposite is true too. I can derive a base class which is not templated, and I can make myself templated. Okay, so let's go back to our code. Let me try to. Okay, let me try to. Okay, go. So this is what we do, and the rest is pretty straightforward. We just replacing all the doubles with T's, constructor, copy constructor, my backup and restore. But these don't use any doubles or any T's at all. Assignment operator and the destructor, and remember the destructors are virtual, and private data members. Remember, I use this guy, use the private base class data members. It didn't use a protected. It could have used it, but it didn't use it, which is better. Okay, so let's look at the implementation. Implementation says that, okay, I am including this PF array backup age, and which includes PF array age, right? Okay, and I write my functions one by one. I replace all the doubles with I replace all the doubles with T's, no parameter constructor, etc. Okay, this one. Okay, backup. Again, I don't see any. This is interesting, see, son? We did that. We are making a T array here. New T. Okay? So it used to be new double, now it's new T. Okay, once I do this, my code can start running. My code can start running like that. Okay, I included all the headers and all the CPPs. Otherwise, this is not going to work. I made a string PF array backup object, and it will work. And I can do like I am doing this. As soon as the compiler reads number 19, line number 19, it produces a whole class. Okay? This happens during the compile time, not runtime again. As soon as it reads line 19, it produces the class code, and it compiles it. If everything compiles, then we are fine. If it doesn't compile, it's going to give us an error message. And this one is possible too. With the templates, such nice abstract code, I can do this too. Okay. And okay. To the array. I have a PF array backup, array of PF array backup. Okay, it's not integer PF array. It is PF array backup of PF array backup. Okay, so it is like a two-dimensional PF array implementation. It's very easy to. I mean, I don't have to think about how the things are stored in the memory, the allocation, deallocation, etc. Very nice example of using applying code reusability. Okay, if you behave smart at the beginning, if you design things right, then your code becomes so simple to use, easy to use. That means reusable code. Okay, good. So, any questions about using the classes with the templates? No? Okay, let's go back to the slides again. We looked at the pair class template parameters. We talked about it. No, we did not talk about it. We are going to know. Okay. We talked about this one. We talked about the pair member function definitions. Let's look at this function now. I have a function int add up. It takes a pair of integers, okay, reference by reference, constant reference, okay. Is this a templated function add up? No, the answer is no. It's not a templated function, okay. It's not a templated function. If I don't include any generic type inside my class function header, okay, this is not a templated function. This is just a regular function. We wrote functions that takes a vector of integers, right? So it is like same thing, okay. I'm writing a function that takes a pair of integers. It's the same thing, okay. So add up is not a templated function. To make it templated, maybe you could just erase this, make it T, and put some template header at the top, but I don't do that, okay? So this one, it looks like it will take a pair of integers and it will add them up and it will return it, okay? So this is all possible, and we wrote such functions many times in your homeworks and in your practices and everything, okay, for the vector class. Your parameter is an instantiated vector class, okay. So any vector instantiation can be, any template instantiation can be used, anywhere a type can be used, okay. But this one is a templated, right? Add up. This one is a templated, but this one is not a very general template. For example, on what kind of classes can I call this add-up function? Just tell me the requirement for the type object, type T, so that this function can compile and run.
Integers, characters.
Well, integer is just one of them. Just tell me the general rule. What kind of classes can I instantiate this template with?
We need to be able to sum.
Plus operator has to be defined for that class, right? So plus operator is defined for what? Plus operator is defined for the integers, doubles, characters, strings. For the strings, plus is defined. Day of year, it is not defined. Vector is not defined, okay? But the basic string class, it is defined, and etc. So that's why it says precondition is operator plus is defined for values of type T. Okay. So that's the condition for this templated function to work. Otherwise, your compiler will give you an error message. Okay, good. Okay, so restrictions on type parameter. That's what I do. Okay, let me try to open the official C++ documentation for vector from the C++.com. C++ reference, this one. So when I open this page, it's going to tell me, okay, what kind of, okay, what kind of T parameters I can get. What should I have for the T? It has to be specified somewhere. Internally instead, just like arrays and etc. Let's go to the requirements of T. I couldn't find it. Did you guys see it anywhere? Type only if T is guaranteed to not to throw while moving. Implementation can optimize. It didn't say anything about that. Maybe it derives from something else. Maybe it was in the header. No, it is not in the header. I couldn't find it for right now, but there must be some kind of a documentation. They say that T has to have a copy constructor. T has to have such and such. T needs to be doing this and this somewhere. And I couldn't find it now. Maybe if I just directly write vector C++ type T requirements. So unfortunately, Stack Overflow. We need to be carefully, okay. Move insertable, default insertable, translated default constructible, and move constructible. So that means that T has to have a default constructor, and we didn't talk about the move semantics yet, which is an important addition to C++ by C++ 11. Okay, so it looks like if this guy is correct, as long as you have the default constructor, then you should be fine. Okay, so such a class is good enough, a default constructor. Okay, and we are going to talk about this one. This one is called move copy constructor. Okay, move semantics will come later. Okay, so with C++ we don't have big 3 anymore. Now we have big 5. 2 more special functions where we are going to talk about it. Without the move semantics, you should be, well, if you don't write your big 3 when it is needed, you will be in trouble. Okay, your classes will behave badly. It will cause crashes for your customers. For the big 5, if it is needed and if you don't write those big 5, okay, which includes our big 3, your program sometimes will work a little bit slower. Okay, so big 5 is not as big as big 3. Okay, So we are going to talk about it later, as I said before. Okay, so that's how you document your templated class. You say that for this class to work, for this template to work, it has to define this plus operator. Okay, so restrictions on type parameter. Only reasonable types can be substituted. Of course, if you keep this restriction list very small, then you have very reusable code. I mean, you cannot get any more general than a class that needs only the default constructor. So that's very general code. Okay. And we talk about this a little bit. Sometimes to make things a little bit easier to use, we do this type def pair of int, okay? So instead of pair of int, I keep repeating this, and I showed you actually this. Our string class is actually type def with this one, basic string character, okay? My string class is something like that, and I can get basic string of doubles and basic strings of anything that you like. Okay, if you feel bad about vector not having the plus operator defined for concatenation, for adding two vectors together one after the other one, then instead of using vector, just use basic string. Okay, basic string will make it possible. And if you are missing the comparison capability of the vectors, I mean, it would have been nice to compare two vectors. One of them is less than or greater than the other one. Then use basic string again. Basic string is, which one is a more general, more generic class? Basic string or vector? Which one is more general?
Vector.
Vector is more general. Why? It doesn't require you to have, for example, the comparison operator, right? I mean, vector doesn't say that I can compare stuff, okay? So, and vector even doesn't tell you that you should have a copy constructor, because vector is not going to move, make a copy of your objects in their position. Okay, vector doesn't do that. Good. What else? Oh yeah. Well, we have many STL functions, STL C++ function, for example, sort. This function is a templated function that takes a container, that takes a sequence container, okay, and it can sort many things, including, in this case it is an array, including vectors. Where is my, okay, not that one, including the vectors. But in that case, our sort is going to be, sort is templated again. Sort is templated again. In that case, it's going to tell you that I am a templated function. I can take this and this and this, and you have to satisfy these rules. Again, I cannot find anything today. So sort this time is going to tell you, even though I can take a vector, okay, I cannot take any type of vectors. Okay, I can take type of vectors that whose elements are comparable with each other. Okay, so that's what we do with the basic string. Okay, basic string says that I can take types that are comparable with each other. Because I have to compare those stuff. And also this one should have copy constructors defined, because remember this catenation thing, putting one vector at the end of the other one, I have to copy stuff. So a copy constructor has to be available for this kind of type. So these are predefined. And what else we didn't talk about? Okay. Since templates are just templated classes, especially are just examples of classes. Whatever you do, you can do with the class, you can do with the templates. We did inheritance with the classes, and we are doing inheritance with the templates. We were doing friends with the classes. Now we can do the friends with the templates too. You can have a friend, non-templated friend. You can have a templated friend, and vice versa. Templated class, non-templated friends, and etc. They are all possible, and they are all used, especially for operator overloads. Okay. Templates and inheritance, I already talked about. There's no problem here. Okay. So that's basically it. With the templates, actually, I hid lots of stuff. Template parameters. Let's look at the C++ template parameters. Yeah. You can have many different things as your template parameters. And I think I am going to look at one of them when we talk about STL. Okay. Okay. How about this? Template auto end. Okay. So it works. It just okay. It just takes it from the, okay. So this is my default stuff. I already showed you this. Okay. Sometimes I can do this kind of stuff. I am going to show you the integers for the template parameters. Did I find it? Yeah. See this one? Template integer I. Okay. Template integer I. What does that mean? Why would I? So it is like calling something, calling an f function, okay, with this parameter and providing the, if it takes a string. Or my class, for example, my class, a templated class, instead of saying integer or double or something, I say 2 and my object. Why would I use such a weird? 2 isn't a type. Where am I gonna use it? Any ideas? Just a small hint for you, okay? Templates are always a compile time things, okay? So wherever I am using this 2 or 1 or double, okay, T, I am handling everything during the compile time. Have you ever written code like this? A function. I have a function, it takes lots of parameters, and it has like a for loop in it, another for loop in it, another for loop in it, very complicated function. And inside here, if this, do A, else do B, okay? So this if is bothering me a lot. Why? Because, I mean, this is the line that is executed many times because it is the innermost loop, right? This is bothering me, especially if I am passing this value, let's say if test is 1, then do A, otherwise do B, and I am passing this test as a parameter. Okay? You see the problem here, right? I mean, I'm calling the function. I know that for this function call, test is going to be 1 or not 1. And every time inside the inner loop, I am going to repeat this test all the time. So how would you solve this problem? This is very inefficient, right? Maybe I can do this. Maybe just copy this code, write it 2 times. If test is 1, then always execute A. If test is not 1, always execute B. So 2 parts, if else part at the top. So maybe that might be a solution. Or we could do this, okay, templated function that takes parameter as integer test, and these are my other parameters, and I say if t is 1, do this other. So what is the difference? The difference is this: when you call this function, you either call it with 1 or not 1 with the parameter, okay, the template parameter. So during the compile time, the compiler knows that if t is 1, it's going to do that. Compiler doesn't compile this part B, and it eliminates the first part because the compilers are smart. Okay. So that's kind of a solution to these kind of problems, if you like to. So it's like the macros, as I said. Everything is handled in the compilation phase of the programs, and you can use these kind of things with the templates. And to understand all of them, just read the documentation. Okay, just read the documentation. I think there are other stuff that I didn't show you. What kind of interesting? Okay, we have seen this. Did we do that? Yeah, class B. I think we have seen all of those. Okay. Template arguments we talk about. So template non-type arguments, constant expression. Okay, like those null pointer, etc. Oh, that's nice. I didn't know this one. How about this one? Well, this is the same as the integer I, right? Now this one takes an integer, but why is it constant? I don't know. I don't remember this one. Just read it. Okay. C++. Did I tell you that C++ is a very complicated language? Only the specifications of the STL library takes like 600 pages, just the specification of the STL library. It's a complicated language, and if you think about it, there are many things that you can do, and there are many there are many things that seems not meaningful, but if you think about it, yeah, well, that kind of makes sense in this kind of data. And here I am talking about only the templates. Okay, only the templates. Okay. This one is interesting. So just read it, and this guy is using this to default template. I already talked about it. Again, we will come to templates a little bit when we talk about the STL classes. Something useful. Sometimes you pass whole classes as an argument, and we use it for sorting and that kind of stuff. Good. Are there any questions about templates? Because I am done. And if I like to talk about it, I can talk about the templates for 2 more lectures. But again, this is not a lecture course about templates. I gave you the initial ideas, and it's up to you to learn the rest. Good. If there are no, yeah, okay.
Not about template, but does abstract class needs an non-parameter construction?
Abstract class does it need a? No, it doesn't have to. No. Well, in fact, I mean, you are saying that I am not going to make any objects of the abstract class anyway. Why do I need an? But remember, when you derive from an abstract class, if you had a concrete class, you most probably you are going to write a no parameter constructor. And that no parameter constructor needs to call the base class's no parameter constructor. So in that case, it would be helpful for the abstract class to have a no parameter constructor, if it has anything to initialize. It's a good idea, it is always a good idea to write a no parameter constructor, even it's going to be empty. Just write this is going to be empty. Okay?
If we don't call parameters constructor in derived class, then no parameter constructors call.
But it will be called automatically.
Okay.
Yeah, it will be called automatically, because even if you don't write it, one is going to be written for you by the compiler, and it will be called. Okay? And if you write it, but if you make it private, then no derivations from you. That for the base class. Well, I mean, you could do the derivation, but in that case, you have to call a constructor with a parameter with the derived class. Good. Any other questions? Yes?
I have a question.
Somebody from the audience. Okay, they have the priority, because it is not every day that I get a question from the online audience. Yeah.
So my question is it possible to call a purely virtual function from base classes constructor?
Sure, yeah, that's what we do all the time. That's what you are going to do with the. That's what you are going to do with your homework. The question is.
I tried, but it didn't work though.
No, but you are doing something else. You are doing something wrong. Well, the question is, can I call a pure virtual function inside a function of a abstract class? Okay. The answer is yes. Yes, it compiles. Okay, it compiles. Of course, to make it run, you need to call that function with a object, and maybe that's the problem that you are having. We did that all the time. Remember, I mean, we did this thing. Where did we do that? Where did we did we do that with the earnings? Did we do that with the earnings of the employee, print earnings? Well, let's go to the employee example. Let's go to the employee example. Can I find the employee example? Let me find the employee example. Where is my employee example? Polymorph is in detail. Okay, here it is. 65. Okay, so this is I employee. Okay, so earnings is a pure virtual, print is a virtual. Inside this print, well, it didn't call the earnings function, but yes, you could. Inside this print, you can call the earnings function. Okay, you can call the earnings function, no problem. And if it doesn't work, just send me your code, and I will try to help you to figure it out.
No, sorry, I actually asked it for constructor, base classes constructor. If we could call a pure virtual function from a base.
Constructor is no different than a regular function. Yes, you could. Yes, you can.
Okay. Thank you.
Well, I mean, but you have to be very careful. I mean, did it give you a compiler error or just nasty runtime crash?
It did give me a compiler error.
Well, I mean, it shouldn't give you a compiler error, but since during the construction time, your objects are not complete, and sometimes you cannot call all of your available functions because your classes are not complete, right? So you cannot call the number of elements in your class without assigning anything to the class, right? So that's what I'm saying. So that could cause a runtime error, that's some logical error, but not compiler error. Okay, just send me the code along with your error message. Okay, you have another question? Yes.
At the beginning of the semester, you said.
I like this kind of questions. So you remember those days? Oh, good, yeah.
You said object-oriented people creates or develops its experience.
If I said that, I am sorry. It has some theory, but there is no proof. There is no proof that, okay, there is no proof that if you do the programming with object-oriented way, your code will be shorter than that and that, and there is no mathematical proof. But in practice, we did this experiment many times. It turns out that if you do the object-oriented programming with the right way of doing it, your programs will be shorter, they will be more maintainable, more reusable. Everything turns out to be nice. That's what I meant.
But we have drilled some holes and we try to cover or close the hole. But we did some fault or mistake in somewhere. But we try to close. Is the people's experience not enough? Because, for example, in front function, some operator overloads
Yeah.
and some global calls. Why the experience is not enough?
Well, I mean, if you, I mean, I talk about the object-oriented programming languages, especially about the C++ programming language in a positive way, because it allows you to be both low level and high level at the same time. It is C, right? And you cannot go any lower than C other than writing your programs in assembly. And it is as object-oriented as almost all the languages. So it is trying to achieve many things, and it leaves lots of loopholes inside the language. Lots of security holes, lots of usage traps, and etc. And if you are not experienced enough, you are going to run into some of those holes. It doesn't matter how many years you have time with C++. When you are in a large project, you will see some places that that's an error, that's a mistake, that's a design error that you have never realized before, even after 10 years of coding. I mean, this is the programmer's, developer's life. You will always run into problems, but that's also the opportunity to, why is the opportunity? Because they cannot automate your job, okay? You need some kind of human intelligence and human, maybe I could say smartness, okay, to figure out those kind of problems. There is no way to, currently, there is no way to write automatic programs as good as humans, okay? I can write sentences, I can write complete documents using artificial intelligence techniques, okay? They read very nice. Sometimes they are not that meaningful, but they are kind of okay. But writing code that makes sense at the level of human developer is not very near, okay? So doesn't matter how many years of experience you have, there will be always problems, and there will be always bugs that needs to be fixed by very skilled people, okay? You know, I mean, Boeing is not a stupid company, right? Boeing. You know, Boeing, the airplane company that makes the airplane. Their last composite airplane costed them billions of dollars, tens of billions of dollars to develop and everything. And at the end, they had a software problem, and they had to delay the production of their airplanes for 2 years because they have been writing the whole system again from the scratch. It was a software error, and they couldn't fix the software error because there was not a single software. They made a mistake at the beginning while designing the whole thing, okay? They say that we are not testing this enough, we are not testing this properly. So they were lucky because we had this virus. All the planes are grounded anyway, nobody was taking it, but they had to write the whole system from the beginning. It is not because the software engineers or the computer science people that the company Boeing employed are stupid. No, they are not. They are as smart as it can get, okay? But this is the nature of this business, okay? So what we can do, you will always accept it, okay? We accept that 30% of the all research and development related software projects will fail. Those are the numbers. 30% goes to the trash, and 70% work somehow, and that's the world we live in, and that's how we need to learn. That's why we need to learn with this kind of word, okay? And what we need to do is we need to try to lower the chance of getting some error from our code from our software projects. That's why we are using object-oriented programming language, not the assembly language. Okay, good. Ask me these kind of questions that starts with. At the beginning of the semester, you did and did and did. Now you are doing this. Those kind of questions are good. Okay, 10 minutes. After 10 minutes, 9:45. We will continue. Where is my attendance? Attendance? Did everybody sign it? Everybody? Okay, so I am done with the templates. Let's talk about some other topic. This topic is something that I expect that you will like, but I think you will get angry with me because I didn't tell you this before. It's called smart pointers. Yes.
You showed us an add-up function. So how are we exactly going to restrict the type of that class template?
It won't compile. The compiler will help you. The compiler will tell you that I cannot compile this code because you are trying to call this one with, you mean the template add-up, right?
Yes.
Because you are trying to call this one with day of year objects, and day of year object doesn't have any operator plus defined.
Okay,
So, well, I mean, remember the documentation. Documentation says that the documentation of add-up says that my precondition is operator plus is defined. So I'm already documenting it. If somebody calls this with a type T that doesn't define operator plus, it's their problem now. Even if it compiles, it runs and produces a wrong result, it is their problem.
What if I only want it to take integers and doubles, let's say?
Well, in that case, there are ways of doing it, and in that case, you could. So you like to make it available for. Well, that's a nice question. I mean, you say that, okay, you do this. The question is this: I like this add-up to work with only with integers and double and nothing else. Is that what you want to do? So this is what you would do. You write this add-up as a template in a add.cpp file, and this is your templated template, okay, dot add up. Okay, this is template add up. At the end of this add CPP, you write a dummy function, void f, and you call this add up with an integer, okay, and you call this add up with double, okay, and in your add.h file you only include the prototypes for the integer add up and double add up, okay. Don't give this to your customer. This becomes an .o file, and whenever they include this add.h, they see only the integer and double versions of this add up, okay, because you didn't give any instantiations for anybody, and that will be it. So they cannot instantiate because they are not seeing your code, right? They don't see your code, or they see it, okay, or they see it. They have a definition for add up, but or it is instantiated with integer and double.
So,
Okay. So
in this case, other than int and
yeah, because I did not instantiate them. I instantiate them in add.cpp with these two only, okay, with these two only, okay, and the code is available. It was compiled and it was put into add.cp, add.o, but in your add.h you are including only these two definitions, and that's it.
so it will give a compiler in this case.
Well, in that case, because I mean there is no code to instantiate for add up for day of year objects, right? Then it will give you at best a linker error because I cannot find this function.
Is it possible?
Most probably no. So it's definitely it's going to give you definitely a template instantiation error. There are other ways of restricting your parameters inside the template. You will say that my template parameter has to be integer or double, okay? So you could use, again I didn't talk about those. You could use C++ template parameters, conditional template parameters, okay? Conditional template parameters. Okay, so in that case, again unfortunately Stack Overflow, somebody is going to tell you, okay, see this one, A, and doing that one. Well, this is doing only, okay, see, this one. So you could say, my type has to be either this one or that one, otherwise I won't compile, okay? You could say that, but I couldn't find conditional template parameters, conditional template types. If you look at it, you can specify those kind of if things. I mean, this one has to be an integer, this one has to be a this and this, okay? So the optional, can I do that? I couldn't find it. Look for it, and you can specify those kind of stuff. I forgot now how to do that. Okay. I couldn't find it, sorry. Okay. The worst thing could be remember type ID. You remember the type ID operator? I talked about yesterday or the other day with the polymorphism. Dynamic cast, type ID. You can get the type of any object using the type ID. It will tell you my type is this, okay? So you can ask for the type ID. If the type is not this, then you would terminate the program. That will be a little bit slow, but it should work. Yeah.
Can we create abstract template classes?
Sure. Why? Well, didn't we? No, we didn't do that. Yeah, of course. Why not? All you need to do is just make a equal to 0 thing in one of the functions. Doesn't matter if it's templated or not. It's going to be an abstract templated class, and you are encouraged to do that. Try to write abstract classes as much as possible. Of course, I mean, it has to be sensible, right? It has to make sense. Otherwise, just to write abstract classes doesn't make any sense. So writing abstract class means that you are collecting the common code, common data in some place, but that place is not complete. It cannot be by a class by itself. So it has to be an abstract. So try to collect common code to some place and derive from it. Yeah, and other questions? Yes?
A programmer responsible for these type of restrictions.
Yeah, well, you are documenting it. As long as you document it, everything should be fine.
I mean, documentation is enough? Would be enough?
Yeah. We are telling that, okay, I am selling you a car, and in the user's manual, it says that in the user's manual, what does it say about the car? Don't hit this car to the sidewalk, right? And if you keep hitting your car to the sidewalk, it will break. It will break itself into pieces. And so, I mean, I've documented it. I warned you, and you are using it the other way. That's why what we are saying about these preconditions, right? Precondition. It just works this way. And what would happen if I don't have a null character in my string and I'm calling strlen? If I don't have a null character in my string and I'm calling strlen, what would happen? strlen causes a crash, right? Because it will keep reading memory until it reaches someplace that doesn't belong to me, and it will crash. Is this a problem of the standard library function strlen? No, it is my problem because I didn't obey the rules. Okay? What does the scanf do if you don't pass a pointer to it? If you pass the value of the integer, it just gives you garbage results back, right? So it is not the problem of scanf, it is your problem. It is documented. It needs a valid pointer to work. Okay, good. Let's go to the smart pointers again. So smart pointers are they were not part of the C++, but later they were added to C++ with C++11. And by smart, they are really, well, they are smarter than our pointers. Let's give an example. So the idea is this: why do we have to delete our dynamically allocated objects? If we don't delete them, okay, it means there is a memory leak. Why don't they delete themselves automatically whenever they are not used at all? That's the idea. So this is what we are going to do. So in C++11, they have added these smart pointers. So the smart pointers are doing that kind of thing. Okay, with C++11, we have this unique pointer and the shared pointer and the weak pointer. We are going to talk about these two of them. But before that, I have stolen these slides from somebody from this university, I guess. I don't know, I keep using it. Whoever wrote this, thank you, if you are watching this. I am using your slides without your permission, I am sorry. Okay, let's look at this one. Let's try to write a pointer class ourselves, a dumb pointer class like the pointer class that we are using. Okay, dumb pointer. So what am I going to do? What kind of operations do I have with the pointers? I have the dereferencing operator, right? I have the arrow operator, and I have the plus operator. Okay, that's what I'm going to do. So it's a templated class. In my private section, I have a t pointer, It could be an integer pointer, double pointer, day of year pointer, doesn't matter. And my constructor takes a pointer and it assigns to this, no problem. The referencing operator returns a reference to my object that I am keeping a pointer of. Okay, return the reference P underscore. Arrow operator, we have never overloaded this arrow operator, but it works this way. You just return the pointer itself and it works as an arrow. And plus plus operator pre-increment, we are not going to overload the post-increment because I don't want to make this class crowded. I increment the P value and I return a reference to myself. Okay, so that's it. So that's behaves like a regular pointer. Okay, it calls a down pointer. Let's use it. I have this integer data 10, and I have an integer pointer, and I initialize with the data, and I can do this. This one is not a dereference operator of an integer pointer. It's a dereference operator of this down pointer class. Okay, this one is not a plus plus operator of the integer pointer. It's a plus plus operator of this down pointer class. Okay, maybe I should show this class definition. Maybe we should show this class definition to the people who learn C pointers first, but they don't know C++. They don't know the templates. They don't know. You know what I mean? I couldn't have shown you this one before the templates. Doesn't make much sense. So this is the earliest that I can show you this one. So down pointer is same as the C pointers, and this is what's happening with the pointers actually, right? So what is missing here? Plus plus, post increment, plus plus, and the minus minus, and plus operator too, right? Plus operator. And do I need a big tree for this class? That's a very good question. Yeah, I like that one. Do I need a big tree for this class?
No.
Who said no? Did you say no? Who said no? You said no. So why did you say no?
Because
It includes a pointer.
Not pointer is just an address, and address is integer value.
In this case, I don't need to make a deep copy. Deep copy would be a bad thing, right? Shallow copy is what we want. We like to copy the pointer itself. Okay? Here is an example for you that doesn't need a big three, deep copy, because deep copy would be a very bad thing for this one. So what did we say about the big three? If you have a pointer inside your class, you most probably need the big three. Well, I mean, it is most probably, it is not all the time. Okay, good. So we don't write the destructor, we don't write the destructor, right? If you delete this P, that would be a problem, because you are keeping a pointer to some thing, and just because you are a pointer, you are deleting it is not a good idea. Okay? Nice class, but its name is down pointer because this doesn't take care of the object that it is looking at, and we are going to change it a little bit. Okay? Good? So we can make a class like a pointer and use templates, and we can keep an actual pointer as a private data and overload operator. That's it. Okay? So this particular class doesn't do really anything useful. It just whatever a regular pointer does. That's it. Okay? But it is a good thing to. It's a good class to see. It's like to kind of review our knowledge of what the pointers do. That's good. So let's try to make this class a little bit smarter. Okay? A useful pointer class. Okay? This is what I am going to do. It's called as unique. Its code name is unique pointer. I am calling it unique pointer because C++ 11 has a standard class name unique pointer, and we are trying to kind of write the same class. Again, this one, constructor. Well, destructor is delete P. That's very interesting. And this is my the reference operator, this operator, and this operator. What does this do? Once you point a newly allocated object with a unique pointer, whenever this unique pointer dies, the space that I'm pointing to is deleted, and that place dies too. Okay, so this is what I'm going to do. Okay, let's say I am making a unique pointer of a string, and I made a new string, and I passed that pointer to this PTR object, unique pointer, and then I print out the content of that object, but the reference PTR, okay, and I didn't, okay, just ignore this part, okay, ignore this part, okay, that was a good example, but when I am done with this class, the function scope, this PTR is a local object, it's going to die, right? Whenever this dies, this destructor will be called, and when this destructor is called, this will delete our object from the heap, and I will be done, okay? So this unique pointer, whenever it dies, it kills whatever it is pointing to. So if you allocate your objects in this way only, if you allocate your objects in this way only, you don't have to delete them explicitly yourself, because they will be deleted by the unique pointers destructor. Okay? What is, okay, this is the good part. I never use a delete in my client code. The bad part is what? What is the problem with this code? What is the problem with this code? What is the problem with this kind of a unique pointer class? Just give you a hint. Just pay attention to the name, unique pointer. What does it say? What does it say? What does the name say? I am a unique pointer, so nobody else is supposed to point to this object in the heap, because if I have two unique pointers pointing to the same object, when I die, I will delete that object. Then in that case, when the other object dies, okay, that object will be deleted again. That will be a bad thing. So unique pointer means that I am keeping a pointer to some object, and I am only the one that points to that object, and nobody else is pointing to it. Okay? That's called unique pointer. Okay? But I cannot live like this, because most of the algorithms that I am going to use will require me to keep more than one pointer to the same object, right? Well, if I am not going to do that, if I am going to keep only one pointer to some object, then I will be fine. But most of the time this is bad, because remember the linked lists? Like this one. So to this object, both of them are pointing a pointer, right? So that's going to be a problem. So in this case, this unique pointer idea will not work, okay? But still, if you can satisfy this, if you can say that there will be only one pointer to this object and nobody else is going to keep a pointer to that object, then unique pointers are fine, and C++11 support this kind of a class. Its name is unique pointer. It is implemented. Yes?
Can we fix that with checking if the P underscore is null pointer or not in the destructor?
Well, you are saying that just make before deleting after deleting this, make P a null pointer, right? Here.
Check it. If it's a null pointer, then delete it.
If it is not a null pointer, then delete it.
Yeah. Sorry.
Yeah. Well, the thing is that, I mean, it's like this. I have one pointer pointing to this object, okay? I have another one pointing to this object, okay? Doesn't matter if it is null or not, okay? Somebody else is pointing to that one. You wouldn't know if somebody else is pointing to it or not, right? This is your value. P is underscore P is your value. And you don't know if anybody else is pointing to the same object. Okay? So, but your idea is nice. You are saying that why don't I use some kind of a data structure to keep track of how many people are pointing to the same object? Okay? So maybe we can do that. For that, okay, for that, okay. So this is what, okay, this is the problem. Did you see this problem? I have a new object, okay, and I use this assignment of PTR to PTR2. So two objects are, two unique pointers are pointing to the same object, and I use PTR2 to print all the words, okay. When I hit here, this PTR2 will die. When it dies, it will delete this new object. But PTR will try to do the same thing again, and that will be a crash or something bad is going to happen. That's a bad thing. So let's do something useful for us, okay? How about this? Did you see what I'm doing here? I made these two private. What are those? This one is what? Copy constructor. Okay, so what kind of slides are they? I mean, I have the slides, but they are not written correctly. So this one is again a unique pointer, and this one is again unique pointer. Okay, so I had both the copy constructor and the assignment operator. Okay, if I hide them, nobody will be able to write a code like this, because this one calls the copy constructor, is the assignment operator, right? This one calls the copy constructor, okay? And copy constructor is hidden, this will not compile. If I try to use the assignment to make the same thing again, that's going to be a problem. So this unique pointer will work now, and it will help me not to point to the same object in more than one unique pointer class object. Okay, but again, if I keep a copy of this pointer new object, then that will be a problem. But it is up to the user now. So unique pointers are nice if you are really a unique pointer. Okay, they are not nice if you need to keep pointers more than once to the same object. For that one, okay, I am going to develop this one, shared pointer class. Shared pointer is going to do this, okay? Shared pointer will keep the count of pointers to the same object, okay? It will count. If I am pointing to the same object more than once, 2, 3, 4 times, that object knows that 5 pointers are pointing to me. And as soon as the number of counts of pointing objects drops to 0, that object says that, okay, it is time to die. I am going to delete myself. Okay, that's what the shared pointer do. It is much smarter than the unique pointer, because it keeps the number of counts. Let's give you a picture. Okay, I made a actual object. This control object keeps a count of it. My shared pointer actually is pointing to the control object. Okay, this is what happens. Okay, shared pointer new object. Okay, and I am calling this doIt function. doIt function takes a shared pointer. So this is called by value, right? So I am going to make a copy of this shared pointer. If I make a copy of this shared pointer, and I have this picture, okay? This shared pointer one, P1 is this. It is pointing to this one. This P2 is this. it is pointing to the same object too. So there are two pointers pointing to the same actual object, and the count is 2. Okay. When I leave this function, this one will die because this is a parameter. When this one dies, the destructor will decrement this number by 1. So instead of 2, this will be 1. So this object will still continue living because somebody is pointing to it. And in this case, this guy is doing a third one, I guess. Yeah, inside the do it, I am doing another one, P3, third one. Okay, when I start killing those P3 and P2, okay, still this one is alive. When I kill the last one, okay, this ref count drops to 0 and object will be deleted too. So this shared pointer is really smart. It keeps the number of pointers to an object. When that number drops down to 0, it is automatically deleted. So you never delete any dynamically created objects yourself. It is automatically deleted. These are called smart pointers, and they are part of C++, C++11 libraries, if you compare it this way. So those classes are already written, and you can check them, you can use them. Okay, this is a very nice example. Okay, so I have a vector of shared pointers, whatever the objects are. Okay, vector of shared pointers, and shared pointer object P1 object new, and I can push it to the vector, and the second one I can push it to the vector and return 0. That's it. I have used 2 new operators on my object class, and I never deleted them, and it works. So how many objects that did I create? Did I create 2 of them? And I have one pointer here pointing to that object, and when I push it back to the vector, so there is a second one. So the picture is this. This is my memory. I have created 2 objects. This is O1 and O2. These are in the memory. These are in the heap. I have one P1 and P2. This one is pointing to O2, and this one is going to O1. This one is pointing to O1. Then I have a vector. This is vector. Okay. One of them is pointing to O1 and the other one is pointing to O2. This is the picture, okay? So when this program ends, this one will die, this one will die, the vector will die. When the vector dies, it kills all the elements of it, okay? And this O1 and O2 will be killed only once, even though 2 different pointers are pointing to them, okay? This is a real code. It can be compiled if you include this memory header, and it will run. Don't delete anything yourself. So it is almost a solution to the infamous memory leak problem. I am not saying that it is all gone. You have to still be careful, but if you follow the rules most of the time, without using any delete keywords anywhere, you will do this. Okay. So from now on, in your homeworks, in your projects, instead of using regular dumb pointers, you can use the smart pointers, shared pointers, or unique pointers. Okay, and let's look at the C++. Where is this? Is this C++ reference? Okay, let's look at the shared pointer. Documentation. Okay, template class shared pointer, and it can take any pointer type. There is a weak type. It is okay. I'm not going to talk about it. So the shared pointer knows about the assignment. Shared pointer knows about the dereference and the arrow operator, index operator, it is added with the C++ 17. Okay, you can ask the shape pointer what is your count. That's nice, right? Okay, so I am pointing to an object, right? I can ask the pointer how many other pointers are pointing to the same object. Okay, and this one operator null checks if the stored pointer is null or not. Okay, just an operator bool. Just the operator bool means that converted to a boolean. So you can say if p1, etc. Okay, good. And these are the non-member functions. I can compare to operator. I can compare to shared pointers, and later with C++ 20. Don't use anything later than C++ 11 because you will never know your compiler will support all of them. C++ 11 is stable enough. Okay, so if you are using any of those, okay, you will be in surprise later in a few years because sometimes you are going to say that this usage is removed after this one and this one. I mean, those are not very stable features. Okay, and many other things. For example, you can swap shared pointer contents between the pointers, etc. So these are the shared pointers. Do I have any code available here? What is this? Okay, I can't find. No. Oh. Okay. No, I'm not going to talk about it. Let's talk about this one. Base and ride. Okay. There is this nice global function make shared. Okay. So you are saying that I am going to make a shared pointer and assign it to this place. Okay. This is one of the, well, this is not a very good example actually. Let me try to find a good example so that we know how to. Okay, C++ shared pointer example. Do I have this? Do I have this? Do I have this? This one? I think I am already looking at this one. Is that? Yeah. I found one nice example yesterday, but I forgot where it was now. Is it this one? No. Is it somewhere here? Shared pointer example? I forgot where it is. Unfortunately, back we are down to Stack Overflow. Okay, so this shared pointer has a number of constructors. Okay, one of the constructors takes a pointer. Okay, just a pointer to that class. The other one uses the result of make shared global function, and both of them are used equally. And now I couldn't find a good example that shows you. Oh my, yeah, I couldn't find it. No, sorry. Okay, I am out of time anyway. So you look this up and try to find examples of this. Shared, make unique. There is another one for the make unique too. Is this a good example? Yeah, maybe this one. Maybe this one. Let's look at this one. Yeah. See, I have a small class or struct with a constructor and a public integer. Okay. This one is good. See this one? I am making, what is 12? Can you read this line? Make shared makes a shared pointer and returns it. Okay? So make shared pointer of class C, but what is 12? So it say that make a new integer in heap, initialize with number 12, okay, and keep the pointer in a shared pointer. So sp1 will be my name for the shared pointer, and it's auto because this make shared already returning a shared pointer. Okay? Good. And then when I say sp1i, it is going to give me 12. Okay? Because my constructor takes. I think I read this wrong. The way I read is okay. Make a new C object in the heap and initialize it with 12 because its constructor takes 12. Okay? And take the pointer and keep it in a shared pointer. Its name is sp1. Okay? So I make a shared pointer here. Here I have a shared pointer, and I assign it to another shared pointer. So both of them are pointing to the same object, but this temporary shared pointer will go away because it's a temporary. Okay? So when I run this line, cout sp1i, it will print 12. Okay? And this one, sp2, is again another shared pointer. This time another object 13, and this one will print 13. And okay, declaration type, okay. This one says that, okay, declaration type of sp1 and okay, declaration type of sp1 and the shared pointer is the same. It says yes. Is this an answer to your question? Another one. You asked me a question about how can I make sure that it can be initializable only. Do you remember that one? So you are saying that this declaration type of this one and integer has to be the same. You can do that. Okay. So 12 and 13 will be the output of it. So this is how you use the make shared. The same thing is available for make unique. Okay? You make a object, but you are keeping a unique pointer to that one. Make unique. Okay, so you look this up, you read more about shared pointers, smart pointers, and we will keep them. In Java, we say that there are no pointers, but in fact there are pointers in Java, but the only available pointer in Java is a smart pointer. Okay, that's why they never teach them that you are using a pointer. They call it references. In Java there is no keyword delete. There is none. Okay, there is only new, because all the things are deleted automatically using this kind of count mechanism. Okay, let me answer one or two questions. Yeah.
Is it a good idea to make a shared pointer or unique pointer type def to make it similar to normal pointers?
Well, maybe not, because if you do that, it's like making a type def to an integer pointer or double pointer. Okay? So write it explicitly so that everybody can understand it. Well, it works, but usually